Assalamu alaikum. So today we are going to solve IGCSE paper 2-3 October November 2025. So let's begin with the first question. What they are asking: when a pendulum passes a marker, a timer display 1 minute 30 seconds. Okay, so this is the timer displaying when it is passing the marker. The pendulum passes the marker 2 more times, 12 more times from the same direction. On the final pass, the timer display a time of 2 minutes and 18 seconds. Okay, how many times it's passing? It's passing 12 more times. Okay, what is the time period of the oscillation of the pendulum? Okay, so first we need to calculate the total time interval. So starting time, I can say starting t is 1 minute 30 second, and ending time is, I can say, 2 minute and 18 second. Okay, so what I can do, if you want to solve it mathematically, you can convert both into the seconds. If I convert this thing into the seconds, so 1 minute is 60 second, so 60 second plus 30 seconds will give you 90 seconds. So it's starting at 90 second, and 2 minutes and 18 is 2 minutes is 2 into 60 second plus 18. So that will give you 120 plus 18, that is 138. Okay, so time interval is 138 minus 90. Okay, so that will give you 48 seconds. Okay, in 48 seconds, how many time it is passing? 12 more times. So what I have to do, I have to find the time period. So time period is for one oscillation. So one oscillation will be equals to 48 divided by 12. So that will give you 4 seconds. Okay, it's option A that is correct. Okay, let's move forward. Question 2. A car driver applies the brake to bring a car. Let me bring this thing. Okay, a car driver is applying a brake to bring the car to a rest with the deceleration of this thing. So you have the deceleration in a time of this, you have a time. What is the average speed of the car during this time? Okay, so average speed we need to know. Okay, so we have the acceleration, we have the time, we have to find the average speed. So for the average speed, what we can find, this is the final velocity, right? This is final velocity 0. Initial velocity we don't know. So we first can apply A is equals to V minus U divided by T. Okay, and this A is also negative because this is the deceleration. So I can write it as minus 4 is equals to 0 minus U, that is unknown, divided by time, that is 8. So this can be minus 4 is equals to minus U divided by 8. This minus minus will cancel out. So U is equals to 8 times 4. So that will give you 32 meter per second. Okay, that is the initial speed. So if you have to find the average speed, what you have to do, average speed is initial speed plus final speed divided by 2. So that is 32 plus 0 divided by 2, that will give you 16. It's option C that is correct. Okay, moving forward to the third question. An object is falling in a uniform gravitational field. At a certain time it reaches a terminal velocity. Which row is correct? Okay, so velocity of the object increases then decreases. Achha, what you need to know, let's suppose object is starting from, this is the starting point. So, and let's suppose this is the point where it reached terminal velocity. Okay, so it is starting from speed is 0, and you need to know terminal velocity, you can say it is the maximum velocity. So it should increase to reach the maximum value. Okay, increasing v, and then it will become constant. Okay, and what about the acceleration? When it start falling, the only force acting on it is weight, but when it reach a lower distance, there is a weight and there is an upward force that is called air resistance. So your resultant force will be equals to, it should be represented by F, that is weight minus air resistance. As we know, as it is keep on increasing the speed, the resultant force will decrease. Why? Because air resistance is increasing, this resultant force will decrease, so acceleration will also decrease. One way is this to understand this thing. Other way is, at terminal velocity we know the acceleration is 0. So if something I have to reach the 0 thing, it means the acceleration should decrease. Okay, so there are two ways to understand this thing. So it has to reach the 0 acceleration, so it should be decreasing to move towards the 0. So it's option D that is correct, that velocity of the object increases then constant and acceleration of the object is positive then 0. Then which measuring instrument is used to compare masses? To compare masses we need a balance, right? Question 5. 3 different liquids are poured into a tall beaker. The liquids do not mix, the liquid densities are shown. What are the correct order of liquid from the top of the beaker to the bottom? Okay, so if this is this thing, dense liquid will sink and less dense will float. This is the basic criteria. So we have the density, smallest density is 1.2, so there should be R. Then greater than is, the highest density is 2.4, so Q should be here, so in between there will be P. Okay, this is, if you see, this is 1.2, 1.8, and that is 2.4, RPQ. RPQ, it's option D that is correct. Question 6. A car is moving in a straight line on a level road. Its engine provides a force on the car. A second force of equal size acts on the car in the opposite direction. Which statement describes what happens? Okay, so what we have, a car is moving in a straight line. Engine provides a forward force and a second force of equal size. So if I take this as a car, there is a forward force and there is a, what you can say, opposite force. They both are equal, so it's mean this is the equilibrium condition. They will balance each other. So when they balance each other, what will happen? There should be a 0 acceleration. The object will not change its state, so it's moving in a straight line already, so its speed should be constant. Okay, it's mean there will be a 0 resultant force, 0 acceleration. Okay, so question 7. Which beam is balanced? You have to ignore the weight of the beam. Okay, so this is from the principle of moment thing. It's mean clockwise movement should be equals to, clockwise movement should be equals to anti-clockwise movement. That will be balanced. Okay, so if I see, for let's try the A, this movement is force multiplied by the distance from the pivot point. So for this clockwise movement, this is 6 multiplied by 1, that is 6, and for this it is, for this force is 3 into 1, and for this force this is 3 into this distance will be taken, okay, from the pivot point, 3 into 2. So this is 6 plus 3, that is 9. So they will not be balanced because clockwise is 6 and anti-clockwise is 9. Okay, so you can check this thing one by one, and let's check the B part. For B part, this force is 9 and its distance from the pivot is 1, so it is 9 into 1, that is 9. That is the clockwise movement. Okay, for anti-clockwise movement force, there are two forces, two moments will be acting, 3, and this distance is 3 into 1, that is 3. There is another force that is 3, and the distance is from this point to this will be 3 into 2. So that is 6. So 6 plus 3 is 9. That is also 9. So they are balanced. It's option B that is correct. Moving forward, question 8. A ball is at rest on the ground and a boy kicks the ball. The boy's boot is in contact with the ball for this time period. This is the time interval. The average force on the ball is this 200 Newton. The ball leaves the boy boot with the speed of this. Okay. So you can say this is the initial velocity. Which row gives the impulse of the boot on the ball and the average acceleration of the ball during the time of this thing? Okay, so you have to calculate the impulse. So this can be the final velocity. Initially it is at rest and it is moving with this velocity. You have to find impulse and you have to find average acceleration of the ball. So for impulse, you have two different relations. It can be written as change in momentum or it can be written as force multiplied by time. Okay, so we have the force. Let's use that one. Force is 200 and time is 0.04. So when we do the calculation, 200 multiplied by 0.04, that will give us 8. So impulse is 8. You have to choose between A and B. And acceleration, we know for acceleration what we need. Acceleration can be A is equals to V minus U divided by T. So change in velocity is 20. That is the only velocity we have, and time is 0.04. So 20 divided by 0.04, that will give us 500 meter per second square. Okay, so it's option B that is correct. Moving forward, question 9. Which device transfer energy from a chemical energy store to a kinetic energy? Okay, chemical to kinetic. Battery stores the chemical energy, but if it is used as a torch, that is changing into a light energy. Okay, if you see the C, a car engine, what it used the fuel. What fuel have? Fuel have chemical energy. That fuel will move car. What is motion of car? That is the kinetic energy. So C is the correct option. Okay. For question 10, which energy resource is the sun the main source? Okay. If you see geothermal, nuclear, tidal, they are not getting energy from the sun. These are only three sources. Those are not getting energy from the sun directly or indirectly. Any source other than them will be getting the energy from sun directly or indirectly. So it will be wind. That is. Question 11. A football is inflated in a warm room and then take outside where the temperature is much lower. The pressure and the temperature inside the ball both decreases. Okay, temperature is decreasing and pressure is also decreasing. The volume of the ball is unchanged, which to explain the decrease in pressure in terms of movement of the air particles. Okay, so temperature decreases, you have to tell about the temperature is directly proportional with the kinetic energy for the particles. Okay, so if temperature decreases, we know kinetic energy will decrease. So kinetic energy of the particle should decrease. Okay, frequency of collision between air particle and inside surface of the ball. Okay, so the frequency of collision is also directly proportional with kinetic energy. So that should also decrease. Okay, so it's option A. Question 12, what we have a fixed mass of gas as a volume of this, let's call this V1. The pressure of the gas is 100 kilopascal, let's call it P1. The volume of gas is slowly decreased by 15. So this thing is not V2, this is basically delta V, change in volume. Okay, and what is the change in pressure? You have to find delta P. Okay, so what is the basic relation we have? We have P1 V1 is equals to P2 V2, but we have P1 and V1, but we don't have V2 as well. Okay, so first let's find the V2. We know if V1 is the initial pressure and the pressure is decreasing. How much pressure is decreasing? 15 degree. That will be equals to V2, the final volume. Okay, so sorry, I'm calling it pressure, it is volume actually. Okay, so 25 minus 15, that will give you 10. So V2 is 10. Okay, that is the final volume that we have. So we need P2 first. So P2 will be equals to P1 V1 divided by V2. So this is 25 into 100 divided by 10. You don't have to convert the values here. So this will give you 250. That is P2. So what we actually need the change in pressure. So change in pressure is basically P2 minus P1. P2 is 250 and P1 is 100. That will give you 150 kilopascal. Okay, it's option B that is correct. Okay. Question 13, specific heat capacity of the ice is given, that is C. Which energy is required to raise the temperature of 100 gram of ice by this much temperature? Okay. Okay, so we have to use what you need energy relation. For the specific heat capacity, we have the formula E is equals to, energy is equals to mc delta T. Okay, so first we have to convert the mass is 100 grams. You have to divide this by 1000 to get in kg. It will be 0.1 kg. Now we can just put the values. 0.1 into C is 2000 and change in temperature is 5. Okay, so doing the maths, we get 0.1 multiplied by 2000 multiplied by 5, it will give you 1000. Okay, joules. So it's option C that is correct. Okay. Question 14, the diagram shows 4 labeled changes of state P, Q, R and S between solid, liquid and gas. Which change need an energy input? Okay, so energy input in which you have to provide the energy. Okay, so if you have to, there are two things. In some cases you have to provide the energy and in some cases you have to extract the energy, right? Sorry. When you are heating something, you are providing the energy. So if something is changing from solid to liquid, you are heating, right? It's mean you are providing the energy. So one is the P process, and from liquid to gas, again you are heating. You are providing the energy. So it is P and Q. Okay, and this R, this is cooling, and this is also cooling. Okay, you are extracting the energy. Okay, so in question 15, which row about the movement of electron and ion during conduction of thermal energy through a metal is correct? Okay. Electrons are called the free electrons. Why? Because they can move through the metals. Okay, they will not vibrate. They are moving freely, and ions vibrate. Okay, they are just like the fixed points. Question 16. A scientist measured the air temperature at the different heights from the floor in a cave. The results are recorded in the table. Okay, we have the two tables. And why does altering the height affect the temperature of the air? Okay, so why the temperature is changing when you are changing the height? So there are the explanation. The particle in warm air have less energy than the particle in the cool air. That is opposite. Warm air will have more energy. Okay, they don't have the less energy. The particles in cool air are further apart than the particle, that is also opposite. The particles in the cool air are close together, they are more dense. Warm air is less dense than the cool air. Yes, that is correct. Okay, so it's option C. D is also incorrect. Cool air rises. No, cool air will not rise, cool air will sink. Okay. Moving forward, question 17. What we have? A star has a larger diameter than star X has a larger diameter than star Y, but both emit radiations with the same power. Which statement is correct? Okay, if you see the star X, let's suppose if this is the star X, this is the star Y. We don't know exactly how big that is, but just for the comparison, and both are emitting the same amount of radiation. So which statement is the surface temperature of X is less than the surface temperature of Y? The radiations depends on surface area. So if the temperatures are same, the X should emit more radiation, right? Secondly, radiation depends on temperature. So if they both are emitting same amount of radiation, even if X diameter is more, its temperature, this is the diameter, let's suppose, its temperature should be less to balance this thing, because this diameter is less, this temperature should be more. Okay, so this will be option A, that is correct. The surface temperature of X is less than the Y. That is the reason why even it has a bigger diameter, it's emitting the same radiation as the Y. 18. When water wave passing through a gap, they diffract. Diagram shows wavefront approaching a gap. Which diagram will the diffraction be least? Okay, so you have to tell the least diffraction. Diffraction is directly proportional with wavelength, and diffraction is, you can say, inversely proportional with the gap width. So first we have to check for the least. Okay, least, the wavelength should be less. So this is lambda, right? This is lambda. So B and C are not the options because they have the greater wavelength. Okay, now you have to choose between A and C. They have the same wavelength. So you will see this has a smaller gap as compared to this one. So bigger gap means less diffraction. So this is the short wavelength and bigger gap that will cause less diffraction. C. Question 19. The diagram shows a scale drawing of the formation of an image by the reflection of the light from the plane mirror. Okay, it's the scale drawing. What are the relationship between the labeled angles? Okay, so if you see this is reflection, this 1 should be equals to 2, yes, and this is again the reflection, the 3 should be equals to 4, yes, it's making angle of incidence must be equals to angle of reflection. So A is making sense, that is correct. We don't have to check others. The speed of light in vacuum is given, that is C. The speed of light in the glass is given, that is V. The light ray in a vacuum enter glass with the angle of incidence I. What is the angle of reflection? Okay, we have two different relations for the refractive index. N is equals to C by V, and we have N is equals to sine I over sine R. Okay, so we can compare both of them. We can write it down like sine of I over sine of R can be written as C by V. Okay, we have to find V, so we have to rearrange this thing, or you can solve it first. Sine of this R will go there, this we are cross multiplying, so sine R is equals to V multiplied by sine I divided by C. V is 2.2 10 raised to power 8 into sine I is 40 degree divided by 3.0 10 raised to power 8. And when you do the calculation, let me do it. What we have sine 40 multiply by 2.2 divided by 3. So I'm getting 0.471, that is sine of R. What we need R, so it will be sine inverse 0.471. So we need sine inverse, that will be 28.12 degree. When you round this thing off, this will be 28. It will not be 29. Okay, so this is 28. Question 21. The diagram shows a human eye that correctly focus the light on the retina. Okay. Which row shows a short-sighted eye and use of correct lens to focus the image? Okay. Short-sighted eye. For the short-sighted eye, the light will be converging before the retina. So they are not the options. You have to choose between C and D, and for that thing we use diverging lens. Okay, so it will exactly collide that thing. So it's option C. Okay, you have to keep in mind for short-sightedness, light will converge before the retina, and you use diverging lens. Okay, concave lens. Question 22. Visible light, X-ray and microwave are all components of electromagnetic spectrum. Which statement about the wave is correct? Okay. Option A. In vacuum, microwave travel faster than visible light. No. All electromagnetic wave travel with the same speed. Okay. Visible have a shorter wavelength than the visible light. No. They have the opposite. In a vacuum, X-ray travel faster than the visible. No. They all travel with the same. In a vacuum, X-ray travel with the same speed as visible light and have the shorter wavelength. That is correct. Okay. So visible light have a shorter wavelength than the X-ray have a shorter wavelength than the visible light, and they both travel with the same speed. 23. Both the amplitude and frequency of sound have wave decrease. What happened to the sound that is you hearing, right? So you know frequency is directly proportional with pitch, and amplitude is directly proportional with loudness. If both are decreasing, so these both things should also decrease. Okay, so it's option D. The sound is quieter and has a lower pitch. Question 24. The diagram shows the magnetic field due to the current in a solenoid. Which graph represents the strength of the magnetic field at position X, Y, and Z? Okay, so this should, in between the solenoid, this should be strongest. Okay, then this will be the weakest because it is very far away. Secondly, you can see the separation between the fields as well. Okay, so this will be intermediate. Okay, so you have to choose the graph. Now if you see, there are different patterns. Okay, secondly, there is another thing that you need to keep in mind. In between the solenoid, the field is uniform. Okay, so it should be constant. It will not be changing uniformly. It will remain constant, strongest and constant. So this is the portion that is Y, that is highest and constant. This is also constant, but that is not highest. This one is the highest value. Okay, so it will be the option C, that is correct. Okay, it's not linear, it will be like this. Question 25. Why does a plastic rod become negatively charged when it rubbed with the cloth? Why it will be negatively charged? Because the rod gains the electron. If something is positively charged, it means it is losing the electron. You always answer in terms of electron. Electrons will be loose or you are gaining the electrons. Okay, you will never talk about the protons. There is an electric current in a circuit with a battery. This question refers to a positive and negative terminals of the battery. Which row correctly describe the direction of conventional current and electron flow? Okay, conventional current, it will flow from positive to negative, whereas they will flow from negative to positive. Okay, so it will be option C. 27. Which electrical quantity is defined in terms of the energy supplied by a source in driving charge around a complete? It's EMF. Okay, electrical quantity defined, EMF provides the energy per unit charge. Okay, you can say it's also mentioned by supplied. Supplied is by the source, by the battery, that is EMF. Okay, a torch has a simple circuit with this much voltage and a lamp. There is a 20 milliampere of current in the lamp. How much energy is transferred to the lamp in 5 minutes? Okay, the battery is connected with the lamp only, so this lamp will also have this voltage. Okay, you have to find the energy. For energy, we have relation V I T. V is 3, I is 20 milli, you have to convert into ampere, so it will be 10 power minus 3. And time is 5 minutes, you have to convert into second, that will be 5 into 60. So multiplying all of them, you will get 18 joules. Okay. Moving forward, question 29. In which circuit does the lamp lights? Okay, so there is a diode in it. You need to know the diode only allow the current to flow in one direction. When it will allow the current to flow, when this side is with positive, this is with negative, the current will flow. When the diode is attached like this, that this is negative and this is positive, the current will not flow. Okay, so if I see this, this is the reversed biased. Okay, this is also, this is positive, this is wrong, the current will not flow. There the current will flow, the current will not flow here. There the current will flow, okay, and there will also it will flow. Okay, so it's option D that is correct, in which the current can flow through the lamp and the resistance as well. Which circuit shows possible correct values for the current? Okay, so if you see the total current coming from the battery is 4, so the same current should reach the battery as well. Okay, the total current coming out of the battery should be equal to the total current coming towards the battery, so that is wrong. B, 1 is leaving the battery and 4 is coming, that is wrong. 2 is leaving, 2 is coming back, okay, correct. When 2 ampere reach there, it is divided into two parts. 2 is divided into 1 and 3, that is not making sense. Okay, here the 4 is going, 4 is coming, that is correct. 4 is divided into two parts, 3 and 1. If you add them, you will get 4, that is correct. Option D. Question 31. The circuit diagram shows circuits that can control the potential difference across a lamp. Which circuit allow the potential difference across the lamp to be varied from 0 to 6 watt? Okay, through the lamp, 0 to 6. Okay, if you see in circuit A and B, this total voltage will be divided in this and this. Okay, you can't make this resistance 0 because it will have some value. So whatever the value, it will have some of the voltage, it will have some of the voltage. So what we have to do across the lamp, this is the lamp. The lamp will never have the 6 watt. Why? Because some of the share will be here, all the cases here as well. Okay, so you can't make it 6 watt in any case. But in C and D, it is possible. If this battery is giving 6 watt to this thing, if lamp is connected in such a way that its one point is here and its other point, this is the slider that you can move this thing. This slider can come here as well. When this slider will come here, this is 6 watt, this will also get 6 watt because its terminals are attached with this thing. So in this case C, it can get the 6 watt. Okay, not in this because they are in series. This is the correct way of connecting the circuit like this. Okay, so it's option C. Question 32. The diagram shows a wire between two magnetic poles. The wire is connected in a circuit with an ammeter. The wire is moved downward towards the bottom of the page. The current induced in the wire, in which direction is the force on the wire caused by the... So what you have to see first, that the current is produced or the force is produced. So if you see the current is induced, so this is the generator effect. For generator effect, you have to use right hand rule, Fleming right hand rule. Okay, so we know the magnetic field is from north to south. This is from right towards right side, and the wire is moving downward. So you have to stretch your 3 fingers of the right hand, thumb first finger, second finger, right angle to each other, and thumb will show you the direction of force when you align first finger in the direction of magnetic field and second finger in the direction of current. What I am getting here is towards the top. Okay, the thumb will be at the top when you align the first finger rightward and second finger downward. Okay. In question 33, some students set up an experiment to measure the count rate for the radioactive source. First, they are measuring the background count rate in the laboratory, and they are each measurement is taken over a 10 minutes period. Okay, and they have taken three readings: 170, 164, 185. And next student measures the count near the radioactive source. The count rate is measured in 949 counts per minute. Okay, if you see, they have different thing. This is for 10 minutes period, and that is per second. Okay, first I have to calculate the background radiation. For background radiation, you have three different readings, so you can take the average of that thing: 170 plus 164 plus 185 divided by 3. So this thing will give me 170 plus 164 plus 185 divided by 3 is 173. This is counts per 10 minutes. Okay, I need counts per second. So for counts, sorry, count per minute, for 1 minute, count per minute will be 173 divided by 10. So that will get 17.3. Okay, now the corrected count rate is the reading that I am getting, 949 minus the background radiation. So it is 949 minus 17.3. So that will be 931.7. So that can be written as 932. It's option A that is correct. For question 34, a radioactive source emit alpha, beta, and gamma into a vacuum where there is a magnetic field. The magnetic field acts perpendicularly into the plane of the paper. Okay, and the path JKL of the three tap radiation through the magnetic field is shown. Which radiation follows path J, K, and N? Okay, what we need, what we know, gamma will move undeflected because it is uncharged. So this is gamma for sure. Okay, and we know alpha and beta move opposite. One thing. Secondly, beta deflect more as as compared to alpha. So if you see, this is deflecting more, so this is beta. This will be the alpha. Okay, so if you see these criterias, it's J is alpha, this is, and this is option B. 35, radioactive decay is a change in an unstable nucleus which may result in emission of alpha particles or beta particles. Which statement describe how this emission happens? Okay, so alpha emission is a spontaneous and random process, but beta emission is not. No, they are all spontaneous and random. Alpha emission and beta emission are both spontaneous and random. This is correct. Okay. Even gamma is also spontaneous and random. Okay. Question 36. Which change occur in the nucleus of a radioactive atom when a beta particle is emitted? So in beta particle, the neutron is replaced by a proton. Okay, neutron break down into proton and electron. It's option B. 37, a radioactive source that emit alpha, beta, and gamma is stored safely in a container. Which material should the container be? It should be a lead. Okay. 38, an artificial satellite orbit planet X at a distance of this. From the center of the planet X, the average orbital speed is given. What is the orbital period? Okay, so you have to apply the orbital speed formula. Orbital speed is 2 pi r divided by t. You have to find the t, so t will be equals to 2 pi r divided by v. So you just have to put the values. 2 pi and r is 7.010 raised to power 6, and v is 3500. Okay, let's do the calculation. What we get, 2 pi into 7 into 10 raised to power 6 divided by 3500 is, you will get 12566.37. That will be in seconds. Okay, we don't have any answer like this. Acha, we have option in minutes and hours, so let's convert this thing into minutes. So in minutes you have to divide this thing with 60. So when you divide this thing with 60, okay, I have this answer in second. I'm dividing this with 60. So dividing with 60, I will get 209.43. That is in minutes. Okay, I still don't have answer like this. Okay, I can convert this thing into hours. So for hours, we have to again divide it by 60. Now I'm getting 3.49 something. Okay, so that is the hour. So 3 hour and few minutes. So D is the option. Okay. In 39, the table lists data about four different stars. Which star is the sun? Okay. So sun is, it is helium, hydrogen, carbon, nitrogen. No, sun don't have the nitrogen, oxygen, and carbon, etc. Not this thing. It is made up of helium and hydrogen. Yes, C and D can be the option, and it emits region of spectrum. It emits IR, ultraviolet, visible. Yes, so it's C. What can be formed directly following a supernova? So after supernova, a nebula and a neutron star. Yes, this can be correct. Okay, so we are done with this paper. See you in the next class.